So have you ever been there, staring at a spreadsheet that's just packed with numbers, and you just feel completely lost? You know, deep down that there's a story in there somewhere, but it's just buried under this mountain of raw data. Well, in this explainer, we're going to find that story. We're going to turn all that chaos into clarity using the tools of descriptive statistics.
You know, every single data set has a secret. Doesn't matter if it's sales figures, website clicks, or scientific measurements. There is a story locked inside all those numbers. The real question is, how do you find the key? How do you uncover the plot, the characters, and the main message that's just waiting to be discovered?
And for this journey, our guidebook comes straight from the experts. We're using course material on descriptive statistics from Indira Gandhi National Open University to break down all the core academic concepts. Basically, we're going to translate that dense textbook theory into practical, powerful tools that you can actually use. This right here is where every data story begins, in pure, unadulterated chaos. You're looking at a spreadsheet or a database that's just overflowing with raw information. It's a jumble of numbers that honestly, on its own, tells you absolutely nothing. It's just noise. So how do we fight through that chaos to find some clarity? Well, that is the entire purpose of descriptive statistics. It's the toolkit we use to summarize and organize all that data, turning that noise into a signal we can finally understand. All right, our very first move is to find the heart of the data. Before we do anything else, we need one single value that gives us a snapshot of what's typical for the entire set. And to do that, we use what are called measures of central tendency.
The key idea here is finding the data's central position. I love thinking about it like its center of gravity. If you had to boil down your entire data set to just one number that best represents the whole group, this would be it.
And we have three main tools for this job. First, there's the mean. That's the classic average we all learned about in school. But then you've got the median, which is the literal middle number when you line everything up. This is incredibly useful for things like house prices, where one billionaire's mansion won't skew the result for everyone else. And finally, the mode is just the most popular, most frequent value. Perfect if you're trying to figure out which t-shirt size to stock the most of. Each one tells a slightly different but really crucial story. Okay, so we found the center. We're done, right? Well, not even close. Does that one number give us the full picture? I mean, if I tell you the average test score in two different classes is 75%, are those classes identical? No way. Knowing the center is a great start, but it's only chapter 1 of our data story. To really get a richer understanding, we have to look beyond the center and see how spread out all the data is. Are all the values clustered tightly around that average, or are they kind of scattered all over the place? This whole concept, the spread, is measured by what we call dispersion. Dispersion is what gives our data its context, its personality. A small dispersion means the data is really consistent, really predictable. A large dispersion means it's all over the map. So let's go back to our two classes. One class with that 75% average might have everyone scoring between 70 and 80, super consistent. The other could have scores from 40 all the way to 100. See? Same average, but completely different stories. Now, the simplest measure here is the range. You just take the highest value and subtract the lowest. Easy. But the most powerful tool in the shed is the standard deviation. It might sound a little intimidating, but just think of it as the average distance from the average. A small standard deviation means everyone's huddled close to the center. They're reliable. A large one means the data is wild and unpredictable. It's probably the single best number for understanding your data's consistency. Okay, so now we have tools to describe a single pile of data pretty well. But the real world is way more complex, right? What if we have two sets of data? What if we want to know if there's a link between, say, how much a company spends on ads and how much money it makes? This is where the story gets really interesting, when we start looking for relationships. And our main tool for this is correlation. It's this amazing thing that boils down a potentially super complex relationship into one single powerful number. This number tells us exactly how strongly two things move together. It's a pure pattern-finding machine.
So we can measure a relationship with a number, which is cool. But what does that relationship actually look like? You know, how can we picture the connection between two things that seem to be moving together?
Well, there are pretty much three main types. You've got positive correlation, where two things move in the same direction. Think ice cream sales and the temperature outside. Then there's negative correlation, where they move in opposite directions. Like the more hours you study, the fewer mistakes you make on a test. And you know, sometimes there's just nothing. No pattern, no connection at all.
Just seeing that a relationship exists is powerful stuff. But what if we want to use it? What if we want to make a prediction? Well, that's kind of the limit of correlation. To take that next step, we need a more advanced tool, regression analysis. This lets us build an actual mathematical model of that relationship. In other words, if we've modeled that relationship between ad spending and sales, regression lets us ask things like, okay, if we spend $10,000 on ads next month, what can we predict our sales will be? It basically turns our data story from a history book into something kind of like a crystal ball.
So let's bring all these pieces together for a second. We started with this chaotic, meaningless mess of numbers, and now we have a structured way to understand it. Each of these statistical tools has been like a different chapter, helping us finally read the story our data was trying to tell us all along.
So here it is, our complete data storytelling toolkit. First, we found the main character of our story, the central tendency. Then, we explored the world they live in by understanding the dispersion. We uncovered the plot by finding correlations. And finally, we even got to peek at the sequel by making predictions with regression.
Ultimately, it really all comes down to systematically describing the core properties of our data. And as our source material puts it, the whole purpose is to make you aware of the three major properties that describe the data. These three things, center, spread, and relationships, are the fundamental building blocks of understanding anything.
But it is so crucial to remember one final thing. After all this analysis, you're not going to have some magical, definitive answer to every single question you have. That was never the point. What descriptive statistics really does is it transforms you. You're no longer just a passive observer of data. You become an active investigator. It gives you the power to look at a mess of numbers and start asking smart, targeted questions. And that, asking the right questions, is where the real story, the one that matters, truly begins.